Yeah, question two. Limits x tends to infinity. The first thing we are going to do is to write this function in another form, exponential form. And how will I do that? Let y be equal to this. Let's give the function, let's give it a letter y. Then the next thing to do now is to take natural logarithm of both sides. Take the natural logarithm of both sides, okay? And this will give you this. And the next thing to do now is to write lim, which is the same thing as logarithm to base e of that function, equal to what? Equal to this. Then the next thing to do now, my y is going to be equal to, everything you have there is going to be on this exponential. So okay, so we've written the given function in exponential form. Actually, they are the same. They are the same thing, because you must bear in mind that natural logarithm of a function, okay, is going to give you, it's going to be equal to that that function, and that is what we have done here. Okay, this form, this exponential form, and this given function, they are the same thing. We now have the limits as x tend to infinity of the given problem is equal to limits as x tend to infinity of this. So let's have L limits as x tend to infinity of this. So what we did is to take the limit of this power, and that's what we call the L. Okay, so and this one is the same as limits as x tend to infinity of ln of this all over 1 over x. And don't forget that x is the same as 1 over what? 1 over x. They are the same thing. If you do the algebra, it's the same thing. Okay? So that's what we have applied in this case. Because what we are trying to do, the moment you substitute here, substitute for your, anywhere you see your x, you put an infinity there, it's going to give you 0 dot infinity. We want to. So when you have such case now, then the next thing to do is to do the algebra of your function so that you can have indeterminate. Okay, so you can have indeterminate either of this form, 0 over 0 or infinity over infinity. Let's do that. If you plug in here, this will be natural logarithm of 1, which is 0, and this one also is 1 over infinity, which is also 0, and that is what? Indeterminate. Apply L'Hopital rule. So we're going to have limits as x tends to infinity. Differentiate this one. That's what the L'Hopital is saying. You differentiate what you have here, the numerator. You differentiate your denominator. So this one is going to be what? 1 over the function, 1 plus this, and then times the derivative of the composite function times what? The derivative of the inner function. So the prime is just the derivative of this inner function all over this one. If you differentiate this one, it's going to give you minus 1 over what? Over x squared. And let me explain that. This is the same as this. This 1 over x is the same as this. So differentiate that. So if you differentiate that, it's going to give you minus 1 and then x to the power what? Minus 2. This power minus 1. Okay? So that's what we have now. Let's quickly get the derivative of this one. Derivative of this one. If we differentiate this one, the x of this, it's going to give you 0 here. And this one is going to give you what? Minus 1 over what? Over x squared. So we're now having now limits as x tends to infinity of this, and then times minus 1 over what? Over x squared. And then let this one, note this is division. Okay, flip it upside down. So times what? Times x squared over what? Over minus 1. So this and this can have limits as x tends to infinity. So if you substitute, it's going to give you what? It's going to give you 1, because this one, 1 over infinity, is 0. So you have 1. Then y is equal to, from here, y is equal to e. Here is what? Over L. E to power what? E to power 1. So we've gotten the e to power 1 equal to what? Equal to e to power 1, which is what? Which is e. And that's that on these aspects. Yeah, the third question, we have the limits of cosec, which is a CSC, x or to the power of x as x tends to 0 positive. I mean, x is more than 0. Okay, so the first thing we have to do is to break this cosec down. Cosec is 1 over sine. So this is sine 0 is 0, 1 over 0. That's what? That's infinity power what? Power 0. So that is the indeterminate form that we have in this case. So in that case now, that calls for us to try to write this one in exponential form. Okay, so then I will now say let y be equal to what? Be equal to this. Then you can take the natural logarithm of both sides, cx. Don't forget your function here. So that's what we have now. Then we can do something. This logarithm is the same as logarithm to base e of your y equal to what? Equal to this. So then y will be equal to what? E to power this. From logarithm, we know that from logarithm says that you can express from logarithm form to exponential form. If you have this equal to will come to the power of this, and that will be a to power c equal to, and this one will come here, that will be b. So you have transformed from logarithm form to what? To exponential form. So here also we have transformed from logarithm form to what? To exponential form. So then the meaning of this is that, so what we are saying is that this function here and this function, they're the same thing. Okay? They're the same thing. Okay. So then the next thing to do now is to let L be equal to limits as x tends to 0 positive of, we'll take the limit of this power. If you do your direct substitution, this one is going to give you, automatically it's going to give you 0 dot what? 0 dot infinity. Okay. Then in that case now, we're going to transform this in the sense that by the time we substitute, it's going to give us either 0 over 0 or infinity over infinity. So let's go do that. So L is equal to limit as x tends to 0 positive ln of cosec x all over 1 over x. Because don't forget that x is the same thing as what? 1 over x. Okay, so that is 1 here. If you substitute now 1 over 0, that's what? This will give you infinity. If you do your direct substitution. Okay, so we're having infinity here. This one also, if you substitute, it's going to give you also infinity. How did I know? Sine, 1 over sine, which is the cosec. Okay, do that. This one, sine 0 is 0. So 1 over 0 is what? Is infinity. And length of infinity is also infinity. So that's why we have that. And that is what? Indeterminate. So then, once we have indeterminate, then the next thing to do is to apply L'Hopital rule. We're going to differentiate this one. For natural logarithm, it's going to be 1 over the function and then times the derivative of that function. I'm going to use prime on top. Okay, that's the ddx of this all over. If you differentiate this one, it's going to give you minus 1 over what? Over x. So then the next thing is that what is the derivative of cosec x? So the derivative of this is going to give you minus CSC and then cot x. And then you can move this one up, and that will be what? Times s squared over minus 1. So this one we cancel, this one we cancel. We're left with the cot. And don't forget, cot x is equal to cos x over sine what? Sine x. So that's what we have there. This one minus here and minus what we cancel. So we now have limits as x tends to 0 positive of s squared cos x over sine x. Okay. So we now have limits as x tends to 0 positive. We can try to do algebra for this one, as in this one over this one. okay, times limit as x tends to 0 positive, x. So I try to split this one into 2, and then times limit as x tends to 0 positive of cos what? Cos x. Okay, just note that limit as x tends to 0 positive of sine x over x is what? Is the same thing. Okay, once you have sine of a function, and that function here and here is the same thing, it's going to be equal to what? It's going to be equal to 1. 1. So this one is what? Is 1. Okay, this one is 0. So everything is going to give you what? It's going to give you 0. This one is also 1. So that's 0. So therefore, L is equal to 0. Limit as x tends to 0 positive of this one will be equal to what? Exponential to power L, which is equal to what? Exponential to power 0, and that's what? That's 1. That's that on this question. Okay. At this point, please, there's a watermarks on the video. Quickly smash the watermarks and hit the notification bell so you can get notified anytime I upload a new video. Click on like button and begin to type your comments. Finally, share the links of this video on all your social media platforms. Thank you for doing that.